Substitution Nucleophilic Unimolecular. This reaction is primarily used for alkyl halide when they undergo nucleophilic substitution. One means unimolecular. This is supposed to be a reaction which is only depending upon the substrate, that is the alkyl halide. Reaction is facilitated more for tertiary halide than for secondary halide and then for primary halide. During the course of Sn1, it has been observed that the attack of the nucleophile can take place from any direction. Since the carbocation which is generated in these cases, that is a planar carbocation, so the nucleophile is welcome from both the directions. Either it can come from above the plane or below the plane, leading to the formation of both the types of products, that is the products which retain the stereochemistry and the products with the inverted stereochemistry. And the result of that comes out to be a mixed product, what we call as racemized product. So let us get into the detail of the reaction. Over to the screen. Substitution nucleophilic unimolecular. Suppose we have tert butyl bromide. We reacted with nucleophile OH minus. What we get is tert butyl alcohol plus Br minus. Is nothing but 2-methyl propane 2-ol. Tert butyl bromide in the first step gives tert butyl carbocation and Br minus. In the second step, mind it, this is sp2 hybridized planar. Here carbon is sp3 hybridized and tetrahedral. Now in second step, this carbocation reacts with OH minus, which is the nucleophile, to give you tert butyl alcohol. The characteristics of the reactions are, it has two steps. It has two steps, and the slowest step is the rate determining step, in which formation of carbocation takes place. The reaction will depend only on the formation of carbocation, so we call it unimolecular. If we write rate law expression, the rate will be equal to rate constant into only the Rx that forms the carbocation. Since we have carbocation involved, the reaction is always stabilized by polar protic solvent. It's a solvent that has got polarity as well as protons, something like water. Also, removal of CO will be stabilized by a solvent, because solvent will stabilize Cl minus, right? So what are the polar protic solvent? We can have water, we can have alcohol, we can have acetate. These are all polar protic solvent. Sn1 is always exothermic. Hence, exothermic equilibrium will always favor low temperature. If we look at the stereochemistry of the reaction, the carbocation that is formed is planar. So the nucleophile can attack from the direction from where Br minus had left, or it can attack from the opposite direction. So what we get is, we get two products. One product will be always same as the stereochemistry, same as the halide, and other will be opposite of that. Other will be reverse of that. So here it will be inverted. So the sum of this is going to be racemization. Sn1 will always favor racemization. Actually speaking, it is not 100% racemization. If Br has removed from here, the nucleophile attack from here will be lesser than from here, right? So where I put an asterisk, here it is going to be a lesser attack, because Br minus is being removed from here, so there will be some repulsion. But on an average, we take it as 100% racemization. NCERT is writing 100% racemization, but otherwise inverted product will always be more than the retained product. So always retention will be less than 50, inversion will be greater than 50. So if we look at the order, always 3 degree greater than 2 degree greater than 1 degree. Let us do an example. If we have alkyl halide or we have tert-butyl halide, both have a tendency to undergo Sn1. Why? Because benzyl carbocation is resonance stabilized and tert-butyl carbocation is 3 degree. But if you look between both of them, it is always 3 degree more than benzyl, because we will have 9, this is going to have 9 hyperconjugative structures because of 3 hydrogen, 3 hydrogen, 3 hydrogen here. That's all for Sn1. And now you understand why polar protic solvent is able to influence the Sn1 more, and why steric factors have no influence on Sn1 reactions. So that was all about Sn1.